Right now, scientists are making something so dangerous that a single gram could level an entire city, and it costs $62.5 trillion. That is not a typo. 62.5 trillion. More than the GDP of the United States, China, and Japan combined. And the craziest part? We have barely made a nanogram of it in over 90 years of trying. I am talking about antimatter. Now, forget everything science fiction told you. This is real. Antimatter is not some made-up fuel from a movie. It was predicted by physicist Paul Dirac in 1928 and confirmed in 1932 when Carl Anderson discovered the positron, the antimatter twin of the electron. He won the Nobel Prize for it. Since then, we have learned something terrifying and fascinating at the same time. Every particle of matter you know, electrons, protons, neutrons, has an exact opposite version. Same mass, opposite charge. And here is where it gets wild. When antimatter touches regular matter, both are completely destroyed. Not burned, not melted, destroyed. They convert entirely into pure energy following Einstein's famous equation E equals mc squared. A single gram of antimatter annihilating with a gram of matter would release about 43 kilotons of energy. That is nearly 3 times the Hiroshima bomb, from something you cannot even see. So why is it so expensive? Because making it is absolute agony. At CERN, the European Organization for Nuclear Research in Geneva, scientists use the largest and most complex machines ever built. They accelerate particles to 99.9% the speed of light inside a 27-kilometer ring called the Large Hadron Collider. When these particles smash together, tiny amounts of antimatter pop into existence for fractions of a second. And I mean tiny. CERN has stated that all the antimatter ever produced by humans would not even be enough to boil a cup of tea. In fact, producing just 1 gram at current rates and costs would take roughly 1 billion years. And that's $62.5 trillion price tag. But wait, here is the controversy nobody talks about. If antimatter and matter are supposed to be created in equal amounts during the Big Bang, where did all the antimatter go? The universe should have annihilated itself entirely. Matter and antimatter should have canceled each other out completely, leaving nothing but energy. Yet here we are. Stars exist. Planets exist. You exist. This is called the baryon asymmetry problem, and it is one of the biggest unsolved mysteries in all of physics. Something broke the symmetry. Something gave matter a slight edge. And after nearly a century, no one can fully explain why. Now, some people ask, could antimatter be used as a weapon or an energy source? Theoretically, yes. 1 gram could power a spacecraft to Mars in weeks instead of months. NASA has actually studied antimatter propulsion concepts, but storing it is a nightmare. You cannot put it in a jar. You cannot let it touch anything. Scientists use magnetic traps called penning traps to suspend tiny amounts in a vacuum. In 2011, CERN managed to trap antihydrogen atoms for about 17 minutes. That was considered a breakthrough. So we have the most powerful substance known to science, and we can barely hold on to it for a quarter of an hour. Think about that for a second. We live in a universe that should not exist, chasing a substance we can barely create that could either solve our energy crisis forever or destroy everything in an instant. If you learn something new, follow this page because we break down the most mind-bending science in ways that actually make sense. Now here is my question for you. If scientists somehow figured out how to mass-produce antimatter, do you think humanity could be trusted with that kind of power? Drop your answer below.